Alright, so this video is to explain how to do enumeration. And we have two different ways of doing the enumeration. One is by using Petrifilms, and these are basically dehydrated plates. And they're commonly used in industry because they're very space-saving, and they're machines where you can just stick it in and read the colonies. So we're using Petrifilms and a spreader, and we're also using Petri plates, agar plates, and then use a spreader, a hockey stick, to move the samples around. But let's go back and dilute our sample first and make sure we understand what a serial dilution is and how to make it. What we use for our sample, and it could be anything, if you're working in a food industry, it could be contaminated apple juice, it could be ice cream that's contaminated with listeria. This method is used for so many different things. What we are using today, we are using saliva. You basically spit into a tube, and we want to find out how many CFU, colony-forming units, you have in your mouth per milliliter of spit. And you may be quite surprised. You probably have never thought about this. So I just spat in this little tube, and we need about 200 microliters. We need to transfer 120, and I'm getting ready for my serial dilution. So I'm using 9 Eppendorf tubes, and I label them successively from 1 to 8, and our last one is our control. So again, labeling everything is really important. So it's -1, -2, -3, -4, -5, I'm just hitting gas, -6, -7, -8, and one more. I want to have good experimental design, so we always want to include a control, because what happens if our PBS isn't sterile, our diluent isn't sterile, and we wouldn't know whether it's from our saliva or whether it's from the diluent. So controls are always really important. Okay, so serial dilution, what it means, it is you're making the same dilution over and over again. So you're from tube 1, diluted into tube 2, diluted into tube 3. So the first step is a 1 to 10 dilution, and then a 1 to 100, 1 to 1,000, 1 to 10,000, and so on. You could also do 1 to 100 dilutions. There are different ways of making serial dilutions, but in this case today, we're just making 1 to 10 dilutions 8 times. In order to do that, and have enough material left for plating 1 milliliter on the Petrifilm. Again, these are dehydrated media, so you need to add 1 milliliter on there. And we also need another 100 microliters to put on our homemade agar plates. So in order to do this, we are using 1,080 microliter of PBS into each one of our tubes, and then we're transferring 120 microliter. This is a 1 to 10 dilution. The reason why we don't do 900 and 100 microliters to make a 1 to 10 is because we need to add 100 microliters onto the 1,000 microliters onto the Petrifilm, and so that's why we need to make the higher volume of the concentrations. Right, I'm starting off with adding 1,080 microliters to each of these Eppendorf tubes with the sterile PBS. I obviously cannot set my 1P1000 to 1,080 because it would damage the pipette. The maximum volume here is 1,000 microliters. But I can add twice 540. So in order to pipette 1,080 microliters into each Eppendorf tube, I can add twice 540 microliters. That makes 1,080 because I cannot set my P1000 to more than 1,000 microliters. Let's get started. 2 times 540 each of my images. Okay, and then I also want to add the same amount in our control tube because I want to make sure that our PBS is sterile and is not contaminated. We may not even see it all if a liquid like this is contaminated. It's totally often not visible at all. Right? So we'll add some more to our control tube so we make sure we have a control in our experiment. So the next step is now we're transferring 120 microliters. Set it to 120. And we're transferring, starting with the saliva I recently collected. Just pipetting 120 microliters. Be slow with pipetting because it's pretty viscous with all the saliva in there as well. Making sure, 120 microliters. Air bubble in there. And then adding this to my first tube. I've got it up and down quite a bit, but I'm going to cap it up and shake it. You have a vortex here in the lab, but for you the best thing is just to shake it up. And then I'll take another 120 microliters from here and transfer it into the second tube to make a 1 to 100 dilution. This is my second tube. And cap it up, shake it, vortexing, and take another 120 out for the next tube. That's my 10 to the minus 3 dilution. Close it, shake it up, and then I'll continue until I'm done up to my 1 to the minus 8. Right, so now I've got all my dilutions done up to 1 to the minus 8, and now I'm ready to plate on my Petrifilms. First of all, I need to label them. I'm going to label my plates with the dilutions, and I'm labeling my Petrifilms with the dilutions as well. And as you can see from the modules, you want to plate only the higher diluted samples. And that's just because we have the experience. We know that there's so many bacteria, and you may be really surprised by the results. Again, it looks like clear water, and it doesn't look like there are any bacteria in there. But let's see what's going to happen once we get our results. Alright, so I'm going to label my Petrifilms with the appropriate dilutions, name, date, and the same with my agar plates. Alright, so now we're ready to plate. I labeled all my Petrifilms, I made my dilution, and now I'm ready to put 1,000 microliters or 1 milliliter on my Petrifilms, and then I put 100 microliters on my agar plates. Again, if you only have 4 plates or something, that doesn't matter at all. I mean, it's 2 different methods that are very similar. So I set the pipette to P1000, which is 1 milliliter. Put a pipette tip on, and I'm starting with my control. So I'm taking 1 milliliter from my control, and make sure you watch the volume. There's not much left. And then I'm lifting up. You can see, you can lift up the kind of lid, the film, the top of the Petrifilm, and you want to put your sample right on there. So put it on a straight surface, and put a milliliter in the middle. You do the same thing with the -8. So you lift it up and put it in the middle. And once we're done with all of them, we use our little spreader and distribute the sample evenly into a nice volume. And because I'm going from the highest dilution to the lowest dilution, I don't need to worry about my packets. Because it will be confusion. Here we go. Okay, now I have my Petrifilms. And now I'm using the little spreader. And if you look at the spreader, it's got like a rugged edge and then a smooth edge. And you want to put the rugged edge down so that you get a nice circle. So I'm going to put this right in the middle, stomp it on, and then move to the next one. You get a nice volume distribution of our sample. It's a nice circle. And now control. Right. So I'm done with my Petrifilms. I'm going to stack them on top of each other and then incubate them at room temperature for 2 days. And you'll see red dots develop. Alright, so let's move on to our agar plates. And again, we only need 100 microliters, 0.1 milliliters, because they're not dehydrated. So I'm now doing the same thing. I'm taking my control first and take 100 microliters, which is just a little bit what's left. And then put it on our control. And that's it. 7, 6, 5, 4. Maybe choose these dilutions here because you know I'm looking at them. Okay, then we use the hockey stick. Again, shouldn't be sitting on a contaminated bench. You're going to get a fresh one. And then we lift the plate and just move the hockey stick in circles so that you can spread the sample evenly. And we'll do this with each one. Start with control and go from the highest dilution to the lowest dilution. Okay, so we're ready to incubate, and let's see tomorrow what results we get.